demo of the Simulink model we have built together upstairs, and we shall see the difference between the practical setup and the simulation setup. Simply, from the first look, if you look at the setup, you will see the machine, just the machine, without anything else. This is the machine, the AC machine, induction machine or asynchronous machine. So the same relevant name. So from the first look, what is the main difference between this AC machine in real time and that AC machine in simulation? Huh? Of course, there is no sensors, there is no measurement, there is nothing. Just the three wires of the AC machine. Why in the simulation, in the Simulink, you have the wires, you have applied load, you have measurement boards, you have an access to all the measurement of the machine. But here in real life, no, you have just the machine. Okay, we need more measurement, you have to use more sensors. We need to measure the speed, you have to use an encoder or a speed sensor. We have to measure the torque, use a torque transducer. We need to measure the current, use a current probe. We need to measure the voltage. It's not an easy use, okay? So you have to bring a sensor, not just double click and select the board you want. It's not that easy in simulation. And this is from the machine side. And also there is a main component of the simulation we have built, which is the three-phase source. Okay, the supply. You can just drag and drop a three-phase source and change the voltage and change the frequency easily by just double click. But here, no, actually, any time we can't use. We have in the lab three-phase supply, but we can't use it. Why? For safety purpose, of course, and because it's a fixed voltage and fixed speed. Fixed voltage and fixed frequency, and therefore the speed will be fixed. But we need to control the speed because sometimes it will be high, low. So we have to find a way to bring an AC, variable AC voltage source. So simply, we will use this device. Okay? This device, which is called, what's the name of this device? Inverter. Okay? This is an inverter. This device is an inverter. What is the main purpose of this device? Converting from DC to AC. Okay, we have here a DC supply which acts as the battery in the electric vehicle. Okay, and DC supply, we will feed the DC source to the inverter, and the inverter will invert or convert this DC to an AC. Okay, what is the frequency of DC supply? Zero. Okay, and what is the frequency of the AC? It is variable, it's programmable. So how this inverter will bring or how it's out or feed the motor with a variable frequency source. So we need a controller. We use this DSPACE, okay? This DSPACE controller, okay? The DSPACE controller. We use it to control the frequency or to control the inverter. Okay, by the way, this is a newer version of DSPACE. Okay, it's more advanced one than this one. This large one. Now this is a small one. Okay, so we use this DSPACE controller. It's actually a real-time controller that we can rely on when you use an industrial application without failure, because you can rely on. Because not all controller you can rely on when you use in harsh environment. An environment where there is noise, there is, I don't know this, the car environment, electric vehicle isn't that pure like in the lab. So we have to use a powerful controller like this. So okay, we use this controller to control this AC voltage, this AC inverter. Why we need to control it? To obtain a variable frequency and a variable voltage from this. So how we will program this controller? From the PC using the Simulink. But we will use this model, the model in the sheet we have built in the sheet. The model exists in the sheet. Just this model will represent the three-phase source to represent the 3-volt source only. Can you remember this block is that you just drag and drop? And this block, we will use it to control the frequency only. And we have the DC source, so it will convert this DC to AC based on the desired frequency and desired voltage. So this is just the rule of the controller, just to act as a programmable supply that we can use even in closed loop control. Okay, so this is the rule of the controller, and we use the interface control disk of DSPACE. We can use it, you can see it. You can use the interface to control the frequency and therefore control the speed. Okay, let's turn on the supply. Okay, the machine is rotating. You can see here the current, the measured current. The current measurement. Okay, the current measurement of the 3-phase, the setting of the cell one need to be adjusted. This is called a current group. What is the main purpose of this current group? To measure the current. How we will use the current? We measure the field produced by the current when it flow in the wire. So just measure the field. Okay? You can see here that if we can measure any phase, this phase, or the current of this phase, or even the third one. What will happen if we measure the 3 of them together? From here. If we measure the 3 of them, what will happen? Let's turn off this one and this one. It will be 0. Okay, so for balanced operation, we have to make sure that the 3-phase is balanced operation, balanced 3-phase current, and the summation of the 3-phase current is 0, so this is an indicator for balanced operation. Also, if you reverse it, the current, this is for example the measurement. If you reverse it, the probe direction, the current direction will be reversed. Okay? You can see here. The peak of the pink one is close to the green. If we reverse it, this one here, this become more far. Okay? So it's just reverse it by 180 degrees. So simply, this current group is just using for the oscilloscope to just to show or to see the current. But we need to feed this current to the controller. Because if you have a controller, you need to control the current. So what we'll use this current sensor. Okay, this is a current sensor. So the same operation, we will pass a wire by this way, and it will measure the magnetic field produced by the current. So we use 3 of them for each phase, 1, and feed it to the measurement board here. Okay, feed it to the measurement board, and this measurement board is the connection between the current sensor and the controller. We connect this measurement board to the controller, okay, to the controller, and we can see the current here. Okay, to reduce a little bit of frequency, you can see the measured current in the DSPACE. So the main advantage between using this sensors or using the current group that we will feed this measurement will be act as a feedback for your controller. You need to measure the current for closed loop control. If you want to make any control technique, you have to measure the current and feed it to the controller. And also we need to measure the speed and the torque and feed it to the controller. So simply, if we change the frequency, the speed will change. Let's try to change the frequency here. Okay, reduce the frequency. The speed, if you can see, the speed is slow. Let's move it like this one. Okay, I don't know if you can see or not. Okay, the speed is slow. We'll increase the frequency a little bit. Okay, we need to increase the voltage. Now increasing the speed. You can hear the voice. So basically, as in simulation, the speed is depend on the frequency. Changing the frequency, but this is an overload control. So changing the frequency will change basically the speed. And changing the applied voltage will increase the ability of the machine, the capability of the machine to produce more torque to handle the losses and the applied torque. Okay? And the applied load determined with what is determined or related to the applied load? The drawing current. If you see, the current is very small actually because there is no applied load at the moment. If we increase the load applied to the machine, the current will be more high until it reaches to the rated value of the machine. So simply we use this DC supply to act as the battery cell or the battery pack and feed it to the inverter, which is controlled or connected to the controller, and you have designed the controller on the PC or your PC, and then the inverter feed the machine, the induction machine, and we take the measurement like speed, torque measurement, and even the current measurement and feed it to the controller for the purpose of closed loop control. What is the meaning of closed loop control? Closed loop control that, for example, you wanted to set a reference for the speed, and it will try to track this speed. If the speed you want it to be 400, for example, the controller will change the voltage, will adjust the frequency, adjust the desired current until the speed track the reference one. Okay. Any questions? Thank you. Actually, electric vehicle is a new trend now. So.
Any questions?
Any questions?
Okay, so I have a question. So if you compare what happens when you apply the pedal down on an electric vehicle with a combustion engine, what's actually happening in the powertrain? What signal does it send? How does the system work?
Can you answer? An electric vehicle, if you press the pedal, what will happen? Basically, in a basic way, an electric vehicle. I give you in simulation. Huh? It will change the frequency. The basic way it will change the frequency, which in turn will change the speed. But it change the applied torque or the desired torque. Change it until the speed follow the reference one or the actual one. So if you increase the torque, the speed will increase. Why? Another question: what is the main difference between the internal, the combustion engine and the electric machine or electric vehicle? This is electric motor and this combustion engine use gasoline, of course. Do you know the efficiency of the combustion engine is almost 40-45%? While in electric machines or electric motors, can you suggest what is the efficiency? Expect what is it?
60 to 70.
It's more than this. Actually, in some types of motors, it reaches to 95 or 98. So it's a great efficiency. It's a great difference between them. Okay? Okay. What is the DC-DC converter in your machine? Why we use DC-DC converter? In last sessions, we have done DC-DC converter. Why we use this DC-DC converter? To reduce the voltage. An electric vehicle, we need to reduce the voltage for the auxiliary battery and the system, the controller, we need to reduce voltage. So the battery pack simply sometimes reach 800 or even 450, depends on the model of the car. But we need 12 and 5 voltage to control this stuff, the controller. So we use DC converter to reduce this. Any questions?
So in acceleration or deceleration, it only uses frequency, does not use voltage, does not change voltage to change the.
No, actually the controller which has built should change the frequency and the voltage, the two of them. This one will be fixed. For example, the 800 of the battery pack. But the controller will change the frequency and the applied voltage and the desired current based on the required speed. So the controller should do this. It's not two things are separated, they are related to each other. The frequency is related to the applied voltage, is related to the drawing current, which is determined by the applied load.
Well, if you change the frequency, does it affect as well?
If you change the frequency, the applied voltage should be changed as well. For example, this is the applied voltage, we will not change it, okay? And we will reduce the frequency. Can you hear this noise? Can you hear this noise? Because this is the applied voltage is higher than the desired one. So the ratio between the voltage to the frequency should be constant. So if we reduce the voltage a little bit, this noise will be disappearing. Okay, so your controller should take care of the voltage, the desired voltage, and the frequency to operate in a smooth and way of course with an efficient way, because we need an efficient control to reduce losses as much as we can.
So in a practical electric vehicle, the controller is connected to the inverter and the DC-DC converter, right?
In practical, yes, the inverter and the DC converter is connected to the battery and is controlled with the controller. Yes, so we control both of them. Because, for example, in old electric vehicles, they were using DC machines. So how they will control DC machines?
DC-DC converter.
Using DC converter, and of course using DC converter. So you need to use a controller as you did in Arduino. The Arduino is the smaller controller. Yes, to control the applied voltage, control the PWM, and therefore control the applied voltage to the machine. So basically, for electric machine or AC, we can see AC machines, we can see AC drives, because the machine has nothing to do without the inverter. So this one is called the AC drive. The inverter with the controller is the drive of the AC machine. So the AC machine itself has nothing to do. The inverter itself will not do anything. And of course, the inverter and the AC machine without the controller, it can't operate. Okay? Any questions?
No.
Thank you again.
Thanks, everyone.
Okay.
Thank you, sir.
I hope you enjoyed.